Now in chapter 14.4, page 10, now I would like to show you that this water is very important for the acids. If we have the citric acid, which is in crystalline form or what we call solid form, when it is not dissolved into the water, when we put the dry blue litmus paper into the citric acid, although it is called citric acid, it still has no acid property. It cannot turn the blue color to the red one. But if you add some water into the citric acid and then try to dissolve some citric solid acid to become aqueous one, then the dry blue litmus paper will turn pink. That means the acid property is given out. Another experiment that can be shown the acid property is about the magnesium. When we put the magnesium into the dry citric acid, it shows no observable change. However, if we dissolve some water into the citric acid, then some gas bubble will be given out. The reason for the water is important because when hydrochloric acid or in dry one, no water there, the hydrogen chloride is a kind of gas. When it dissolves into the water, it will become the H plus AQ. Now the H plus AQ is the key, plays the key role for the acid property. So if the H plus AQ presence, then the acid property presence at the same time. So when HCl put into the water, we say that this is a kind of dissociation. Dissociate the acid into the H plus. So dissociation occurs so that H plus and then chloride minus will be given up. For the acid property, mainly due to the H plus present. While in our textbook also mentioned about H3O plus. Now the H3O plus is another new stuff. Actually, for H plus, it is a kind of hydrogen ion. We can say that H plus already bears the acidic properties. But as H plus means what? H plus means it just bears a proton without any electron. The electron has been gone, no electrons there. So that it's just bear one proton inside, and then this is the equals to the hydrogen ion. So it is very, very reactive. And then the H2O, the lone pair electrons in the water, as we dissolve into the water, there are lots of H2O. The lone pair will attract to the H plus to become hydrosonium ion or hydronium ion. So this kind of hydrosonium ion, H3O plus, also named it as acid as well. So you may treat H plus as an acid, while H3O plus also as an acid as well. If H plus or H3O plus presence in the solution, it is a kind of acid. It bears the acid properties already.